Welcome to this explainer. Today, we're tackling something absolutely fundamental, the very nature of how we teach and learn. Look, for over a century, traditional teaching methods have been the norm. And let's be honest, they've often resembled factories designed purely for standardization. But right now, those old methods are suddenly facing a massive existential crisis. We're operating in a completely new era, and the old ways of doing things simply aren't going to cut it anymore. So today, we're going to explore the active strategies required to teach critical thinking and true, deep understanding in modern education.
Okay, let's dive into this. We have to face an urgent reality right off the bat. Fact retrieval is simply no longer a human advantage in education. In an age where artificial intelligence can retrieve pretty much any fact instantly, the future of education definitely does not belong to students who merely memorize information. I mean, if all we do is ask students to recall facts, we're essentially preparing them for a world that no longer exists. The future belongs entirely to those who can analyze, synthesize, debate, question, and innovate.
Think about this quote for a second. The modern classroom must evolve from a place of passive consumption into a laboratory of ideas. This isn't just some minor tweak to a Wednesday lesson plan. This is a foundational ground-up shift in philosophy. We have to move entirely away from the passive reception of information. Deep learning, the kind that actually sticks, only happens when students actively construct meaning for themselves.
To make that shift, we literally have to rethink the physical and mental space of learning. The absolute best classrooms are not silent rows of compliance. They don't look like industrial factories at all. Instead, they look like design studios, think tanks, laboratories, seminars, and collaborative communities of inquiry. Thinkers like Socrates, Maria Montessori, and John Dewey, they understood this over a century ago. And it's something modern neuroscience is absolutely confirming today. Knowledge has to be discovered, not just delivered.
Section 1. Mastering Dialogue and Debate.
So how do we actually pull this off? Let's open up our first practical toolkit, which is all about building real discussion depth through structured student interaction. We're shifting from asking who knows the answer to asking what is truth and how do we know it. And this brilliantly illustrates exactly what we mean. Consider this driving question for a high school English class reading The Great Gatsby. This kind of prompt is the foundation of a Socratic seminar. In this method, students sit in a circle and engage in dialogue. But here's the kicker. The teacher does not lecture. Students can't just randomly state an opinion. They have to point directly to a specific quote or scene in the text to back up what they're saying. It anchors the whole discussion entirely in evidence and peer-to-peer inquiry. Taking that student ownership a step further, let's talk about the Harkness method. Picture this. Students sit around an oval table, and the discussion becomes entirely driven by them. They lead it, they question each other, they facilitate, and they synthesize the information. And the teacher? Well, the teacher becomes a silent observer, maybe an occasional guide, but that's it. This teaches students such a vital lesson, that understanding is socially constructed through conversation, collaborative reasoning, and active listening.
Now, how do we handle those really difficult, highly polarized topics? Enter the structured academic controversy, or SAC for short. Let's walk through it. First, Team A argues their side while Team B takes notes. Second, Team B must repeat Team A's arguments back to them until Team A feels fully understood. Third, the roles reverse. And finally, and this is the best part, both teams drop their assigned sides, sit together, and write a consensus statement. It's an absolute genius way to navigate complex issues without turning the classroom into a shouting match.
Just imagine applying those SAC steps to a massive biology question, like this one about CRISPR gene editing. Team A argues for the elimination of disease. Team B argues against the unknown ecological risks. By forcing students to actually repeat the opposing team's argument until they feel understood, you are forcing them to practice deep, genuine listening. They have to map out the ethical versus the scientific arguments. They quickly learn that strong arguments require evidence, perspective taking, and logic, not just volume.
Moving on to Section 2, Mapping the Interconnected Web.
Let's shift gears to our next category of active strategies. This one is all about making cognitive connections and conceptual patterns physically visible to the student. We're moving from linear thinking to mapping out an interconnected web of knowledge. A fantastic tool for this is called hexagonal thinking. You give groups of students a deck of movable hexagon-shaped cards. Each card has a vocabulary word, a theme, a historical figure, you name it. Students must physically arrange the tiles so that the sides touch, but they can only touch if there's a direct conceptual link, and they have to justify that link out loud.
The brilliance here is that multiple answers can be completely correct, making their thinking dynamic and systems-based, rather than just a flat, isolated list of facts. It's like a giant puzzle of ideas. Now, what's really interesting about this slide is how incredibly adaptable this strategy is across totally different subjects. In English, students might connect themes from Romeo and Juliet, like fate, Friar Lawrence, and the feud. In history, they use it to link causes, events, leaders, and outcomes, so they can actually see the whole picture of an era. In science, it helps them explain exactly why a complex model or process works. It fundamentally forces students to stop viewing knowledge as isolated data points and start seeing interconnected networks of meaning.
Section 3. Real-world problem solving. This brings us to our third category, which is where we move students beyond the theoretical and into messy, authentic realities. Think about traditional passive tasks, like completing worksheets about pollution. Now compare that to project-based learning, where they are actually testing local water quality and proposing real policy. In project-based learning, students investigate authentic problems over an extended period. They might design sustainable communities, interview local experts, or build physical prototypes. Learning deepens tremendously here simply because it has a real-world purpose. It's not just for a grade anymore, it's an actual solution.
A close cousin to this is case-based learning. Here, students analyze realistic scenarios that frankly rarely have simple answers. We're talking about ethical dilemmas, tough historical decisions, medical cases, engineering failures, business challenges. Students have to weigh the evidence, evaluate competing perspectives, and justify their decisions. This develops incredible analytical judgment because it teaches them that real-world problems are inherently ambiguous and complex.
And finally, Section 4, the new literacy.
As we bring this explainer toward its conclusion, we need to tie all these active strategies, the Socratic seminars, the hexagonal thinking, the project-based learning, together under one guiding practical rule for educators. And that rule is the rule of 3. If you want deep understanding in your classroom, you have to choose methods that make students do at least 3 very specific things. It's a fantastic metric to evaluate your own classroom dynamics right now.
Here's the breakdown. Students must do 3 actions. Number 1, explain their thinking. Number 2, justify that thinking with actual evidence. And number 3, revise their thinking in real time based on new information or peer dialogue. To truly construct meaning, these 3 routines are completely non-negotiable. And notice something important here. The best versions of these routines do not involve teacher talk. They require clear norms, structured student action, and follow-up reflection to strengthen their metacognition. Their ability to think about their own thinking.
So the crucial point is that we are experiencing a massive paradigm shift. The goal of education is no longer simply to produce students who can recall information. We have machines for that now. The goal is to cultivate human beings who can think independently, evaluate truth, solve novel problems, and collaborate ethically. In the age of AI, critical thinking isn't just some elective skill anymore. It is literally the new literacy.
Which leaves us with this final, vital question. How will you redesign your classroom for the new literacy? The tools are right in front of you, from Harkness discussions to structured academic controversies. The shift from passive compliance to active inquiry is waiting. I really hope this explainer has given you the structural blueprints to start building that laboratory of ideas. Dive into these strategies, experiment with them, and watch the depth of understanding completely transform.